Hello, this is my video on the Dead Sea Lab. And so tables 1 and 2, we converted both tables to moles per liter. Table 1 was initially grams per liter, and so we had to use the molar mass of each one to convert it. And then table 2 was grams per 100 milliliters, and so we used the molar mass and then also converted it to liters. And so for the rice table, to find the KSP for NaCl, we start with some NaCl solid, and we start with no initial sodium or chloride, and we add X because there's only 1 mole of each thing, and so we subtract X. And so the KSP calculation is Na plus times the concentration of Cl minus, which X, as we see in table 2 here, 6.11, and so that's what we use for the X. X squared is 37.32 for the KSP of NaCl. Then for this one, we have some of the solid and then initially none, as just like the last one. But this one is going to be plus 2x because there's 2 chlorides. This one's also plus x. And so for x, we use this value right here for magnesium chloride, which we found from converting. And so the KSP calculation for this is the concentration of magnesium and chloride. Well, the chloride is squared because there's 2 chlorides. So the KSP is 4x cubed, using that value that was in table 2, is 739.99. Now the KSP for magnesium sulfate, we start with some, initially none of the individual ones. And then since there's only 1 mole of each one, it's just a plus x on each of them. So the KSP calculation, concentrations of both of these is going to be x squared, and as we see in table 2, magnesium sulfate 2.16, 2.16 squared, x times x, 4.67. And now this is the amount of sulfate needed, and this is the overall charge, 0.0277, 0.01385. There we go. Now, the Q calculations is basically the same, Na times Cl, but for these ones, we use table 1's values. So sodium chloride, we use the sodium, which is 1.74, chloride 6.32, and we end up getting 11.02 and change. Now, same thing for the magnesium chloride. We have the chloride from earlier, which is squared since there's 2 of them. And then we have the magnesium, 1.81, right here. And now the last one, magnesium sulfate, 1.81 times 0.0139 equals 0.0252 magnesium sulfate. And so comparing the Q and K, if Q is greater than K, that means a precipitate forms. So comparing number 1, sodium chloride, the K is obviously larger than the Q, so the precipitate does not form. Same thing for this one. K is way larger than the Q, does not form. And same thing for this one. It's larger, so precipitate does not form. Now, sodium chloride is the salt closest to precipitating. It was calculated that the QSP value for sodium chloride was 29.53% of the KSP value, so it was the closest to having enough of the salt to make a precipitant. How do you stop it?